Hi, Questers. Today's inquiry begins with a glitch in reality. Every winter, a specific, impossible scene unfolds across the vast plains of northern India.
The sun rises over Delhi, but it doesn't shine. It hangs in the sky like a pale, bruised coin. Buildings dissolve into gray silhouettes. Streetlights glow at noon to cut through the haze. Your eyes sting. Your chest tightens. Breathing stops being a reflex and starts feeling like work. And yet, if you look at the raw data of the world, something doesn't add up. There are other megacities on Earth, Tokyo, Beijing, New York, that have more factories, more vehicles, and higher population densities. Yet, they do not disappear beneath a toxic cloud like clockwork every November. Delhi does. Not randomly, not occasionally, but predictably. This forces us to ask a question that shouldn't exist. Why does the air suddenly become deadly when the pollution sources haven't changed? Factories don't multiply overnight. Traffic doesn't triple in a week. The number of exhaust pipes on the road remains almost constant. So why does the air behave as if the pollution load just exploded?
Most of us have a reflex answer. We point fingers. It's the cars. It's the firecrackers. It's the stubble burning.
It feels intuitive. More smoke equals worse air. But before we accept that, we have to look at the numbers, because the numbers tell a very different and much more disturbing story.
Let's look at Delhi's patient chart for the year 2025. Surprisingly, the city was not toxic all year round. In fact, for over 200 days, the air was classified as moderate.
During the summer heat and the monsoon rains, nature acted like a massive scrubbing brush. The heat lifted pollutants up, and the rain washed them down. For weeks at a time, Delhi breathed almost like a normal metropolis. Then, the calendar turned to winter. The numbers didn't just creep up, they jumped off a cliff. The AQI shot past 300, then 400. By December, monitors were flashing 450, levels where the air itself becomes a biohazard. Here is the scientific mystery. The city didn't change. The emissions didn't explode. The air did. Same people, same traffic, same activity, but a completely different set of physics. So if the sources stayed the same, what actually broke? Delhi's crisis isn't just about how much pollution we create, it's about what the atmosphere allows. In winter, the city doesn't fail because we emit more. It fails because the air stops behaving like air. To understand this, we have to look at thermodynamics. Under normal conditions, the ground is warm. Warm air rises. It acts like an invisible conveyor belt, carrying smoke and exhaust up into the upper atmosphere where winds disperse it. Ideally, the atmosphere is a giant mixer, constantly diluting our toxins. But winter flips this switch. The ground gets cold and the air touching the ground becomes dense and heavy. It refuses to rise. Meanwhile, a layer of warmer air settles on top of it like a lid. This phenomenon is called temperature inversion. Think of it like this. Imagine lighting a stick of incense in an open field. The smoke trails up and vanishes. Now, imagine lighting that same stick of incense inside a sealed glass box. The smoke has nowhere to go. It hits the glass lid and circulates back down. In winter, Delhi becomes that glass box. Every engine, every flame, every exhaust pipe creates smoke that hits that invisible lid and bounces back into our lungs. We aren't breathing new pollution. We are breathing trapped history, accumulating hour after hour. Beneath the physics lies the geography. If you look at a topographical map, Delhi sits inside the Indo-Gangetic plain. It is effectively a massive, shallow bowl. To the north, the Himalayas act as a giant wall, blocking wind flow. To the south, the land rises. The city is landlocked, hundreds of miles from the coast. There is no sea breeze to flush the toxins out. When the winds die down in winter, the air becomes stagnant. Geographically, the city is designed to trap air. Once the air is trapped in this bowl, chemistry takes over. We tend to think of pollution as simple soot, dust floating in the air. But inside the bowl, it's more like a chemical soup. Gases from cars and ammonia from farms cook together in the sun. They react. They combine to form secondary aerosols.
What began as simple exhaust smoke transforms into complex biological hazards, particles small enough to slip past your lung barriers and enter your bloodstream. The longer the air sits still, the more toxic the soup becomes.
This is why a single rainstorm can clean the city overnight, and why bans often feel ineffective. We are at the mercy of the system. The bowl decides if we breathe, not the traffic lights.
Historically, humanity treated pollution like litter on the street. Just pick it up and it's gone. We thought if we just filtered the smokestacks, the sky would clear. But the great smog of London and the hazes of Los Angeles taught us a harsh lesson. Scientists realized that pollution peaks were happening without emission spikes. They discovered that the air isn't empty space. It is an active, volatile chemical reactor. We can't just manage the garbage. We have to manage the meteorology. Even today, the sky keeps secrets. We can predict the weather, but predicting exactly how that chemical soup will evolve hour by hour is still a scientific frontier. So the question shifts. Can Delhi ever escape this trap? The answer is conditional. First, let's look at the hard limits. We cannot move the Himalayas. We cannot install a giant fan to create a sea breeze.
We cannot rewrite the laws of thermodynamics. The bowl and the lid are permanent features of our geography. We cannot rely on nature to disperse the smoke, because nature has closed the exit.
When the drain is plugged, there is only one way to stop the bathtub from overflowing. You have to turn off the tap. This is the only scientific escape route. We have to lower our emissions below the inversion threshold. Think of the atmosphere like a sponge. In summer, the sponge is huge. It can absorb a lot. In winter, that sponge shrinks to a fraction of its size. To survive, our pollution output must fit inside that smaller sponge. It's not about zero pollution, it's about staying below the atmosphere's breaking point.
To do that, we have 3 mechanical levers.
Lever 1. Combustion reduction. Physics is a blind accountant. It counts every particle from every fire, car, and power plant. If we don't reduce the volume of things that burn, the reaction continues. This means electric transport isn't a luxury. In a trapped airshed, it's a survival mechanism.
Lever 2. Dust control. In winter, dust isn't just cosmetic dirt. It acts as a catalyst, a surface for toxic gases to latch onto and multiply. Dust particles are the scaffolding for the chemical weapon. If we leave the dust, we amplify the toxicity. Lever 3. Synchronizing with the sky. This is the missing piece. We try to run the city at full speed when the atmosphere is in hibernation. We need to synchronize our activity with the stability of the air. When the lid is on, the city must slow down. We need a dynamic city that reacts to the sky. This explains why half measures feel useless. Pollution control is nonlinear. Imagine a dam that is overflowing. If you remove a single cup of water, the dam is still overflowing. You don't see a change until you reduce the water level below the rim. That is the threshold. Nothing happens until suddenly you cross the line and everything changes. Delhi is a harsh lesson in a global reality. For a century, we designed industrial civilization assuming the sky was an infinite garbage chute. We thought away was a real place. Delhi proves that away does not exist. The atmosphere is a closed system. It is a finite sink with a limited capacity to absorb our waste. When we treat a fragile machine like an infinite void, the machine eventually jams. This forces us to ask a terrifying question. If our cities can grow faster than the atmosphere can handle, what other invisible limits are we currently speeding toward? We are hitting the walls of our own fishbowl. Delhi's pollution isn't unsolvable, but it cannot be solved by negotiating with physics. The atmosphere will not adapt to us. We must adapt to it. Questers, if today's inquiry opened a new doorway for you, follow the next one. Every mystery we solve only sharpens the next question. Subscribe to keep the quest alive.